Great, and we are live. So I have Sam here from Semiotic AI. He's going to give you an intro into their technology today. And if you have any questions in the meantime, feel free to pop them in the chat and we can answer them towards the end. Sam, I'll let you take the stage.
Thanks, Richie. Hi everybody. Today I'm going to be talking about Semiotic AI. We are also the creators of Odos.xyz. We're sponsoring a prize for the hackathon, and really my goal for today is to tell you a little bit about our company, some of the things that we're working on, some of the job opportunities that we have, and then also how Odos was born. And like Koichi said, if you have questions, I have the chat window open, so I'll see them, and I'll respond to them. Actually, my chat window disappeared. So yeah, I'll also ask for questions at the end if I don't see your chat. Okay, so Semiotic was founded about 2 years ago, and our initial focus was on fully homomorphic encryption. And FHE lets you compute directly on the encrypted data. So for example, you could encrypt two numbers, A, and then encrypt B separately. And then you could send it to an untrusted cloud provider, and they could then add A and B or do whatever they want to A and B, and only you can decrypt the results. So with that work, we were funded through the US National Science Foundation and DARPA, but we weren't really getting other traction outside of the government funding. So a year into the company, we pivoted into Web3. And so then our pivot was to work with the graph. And we worked closely with the graph for most of the year last year. And then by the end of the year, we got a core dev grant with the graph. So now we're one of the 5 core dev teams working with the graph. And we're also the creators of Western Gate, which I will introduce. It's an arbitrage measurement project. It was actually created through ETH Global about a year ago in June through a hackathon. And we still maintain it because we think it's interesting. And then through Western Gate, so Western Gate is an arbitrage measurement website. And after Western Gate, it was we created Odos, which is a related tool for making swaps. It's a DEX aggregator. And so I think a lot of people, ETH Global is famous for basically a lot of the projects or hackathons that are worked on in ETH Global end up turning into products a lot of times. So I'm a big fan of ETH Global and this hackathon and the hackathons that they run. So I am Sam Green. I am the head of research at Semiotic. My academic background is in computer science, and I have a focus on reinforcement learning, which is basically a class of AI algorithms that uses trial and error learning. That's how DeepMind won or built a bot that solved, quote unquote, the game of Go. And if you want to follow me on social media, I'm on Twitter at 0xsamgreen. Okay, so I'm going to tell you a little bit about the graph. I don't know if the graph is also sponsoring ETH Global. I assume that they are. But yeah, like I said earlier, we're one of the core devs in the graph. And the goal of the graph is to make getting access to blockchain data easy. And the graph is a decentralized Web3 protocol for indexing and querying blockchain data. And I'm going to show you what it looks like, what using the graph looks like. So here, this is a website, this GraphQL online. It's an explorer for graph data. It's just an open source. It allows you to actually interact with any GraphQL endpoint. By the way, GraphQL, there is some kind of initially, a lot of people who aren't familiar with GraphQL get confused about GraphQL and the graph. GraphQL was invented by Facebook as a query language that was easy to use. And it's now used by many different companies and many different projects. It just so happens that the graph also uses GraphQL. So GraphQL is a GraphQL endpoint. So anybody who has a publicly accessible GraphQL endpoint, you can explore the endpoint with GraphQL. And so here is the graph's mainnet endpoint. And so really we're using the graph to look at participants on the graph. Like I said, the graph is a decentralized service. So there are many different people, different users using it. So here's an example of looking at the graph's data with GraphQL. And what I'm doing here is this is a GraphQL query if you've never seen one. And what I'm doing here is I'm looking for the first 10 indexers, and I'm ordering those 10 indexers by how much stake they have, and I'm getting it in descending order. And so here you can see here's the result. But GraphQL, it makes it really easy for you to get data, and that's why the graph is really popular for building dApps, because you can just query this and then you can show it to your users and your dApps. Related to the graph, we have the Graph Day coming up on June 2nd in San Francisco. I think that there are still, so we have the Graph Day on June 2nd, and there's gonna be a bunch of protocols, not just the graph, talking on that day. And then there's a hackathon on June 3 through 5. And I'm not sure, but there were travel scholarships that were being available. I'm not sure if there are still any available or not. If you're around the Bay Area, then ticket prices were just dropped to $100 for Graph Day. And if you paid more than $100, you'll automatically get refunded for whatever you paid for your initial tickets. Okay, so Semiotic, going into this, our core expertise. One of the areas of our core expertise is reinforcement learning, and within the graph protocol, we've done a bunch of RL related activities. One of them is we made reinforcement learning agents for optimal bidding. So in the graph protocol, it's a data market where you have buyers and sellers of data. This is part of the decentralized aspect. There is no centralized service that's setting the price of data. It's all participants in the market that are choosing how much they're going to sell the data for and how much they'll buy it for. And this animation you see right here was one of our early experiments. Actually, I'm gonna explain how it works, I'll show you this video and then I'll explain what you're seeing. What on this bottom plot, we are seeing that we're looking at how much the reward of the agent is getting. So an agent is basically being trained over time in this video. And what you want to see in RL is you're always trying to maximize rewards. And so what we're seeing is that during training, the rewards of the agent, this is for consumer agents. So the reward is going up because the consumer is learning to maximize what it cares about. And we can see that the error bars, that's the standard deviation per each training time step. And we can see that as time goes on, the agent is doing better and better. And what is it learning to do? Well, it's learning to make a bid that maximizes its reward. In this case, the reward is balanced between how much it's paying and the performance of the requests that it's getting. So basically the latency that it's getting. And so you can see that it's learning to make a bid that's more and more optimal over time by trying various bids. And so these various bids are represented, its bidding strategy is represented by this Gaussian distribution, and the Gaussian gets tighter and tighter around a certain price point. And so it becomes more and more confident. So that's an example of using, with this RL agent, you could then deploy something like this onto mainnet, And you could allow this thing to work on behalf of users on mainnet so that they could learn to optimize their price and performance. We've also implemented our algorithms for automatic two-party negotiation. So imagine you wanted to allow a consumer and indexer to agree on, let's say, a quality of service. We did some very early experiments on that line. We haven't solved the quality of service negotiation yet, but we did some interesting things. We've also, this is actually related to optimization and not RL. We've built a portfolio optimizer tool for indexers. So indexers have a really difficult resource allocation problem where they have to basically stake or allocate their tokens to the subgraphs for the data they want to serve. And so, for example, a subgraph Uniswap would have a subgraph, LivePeer has its own subgraph, Pulled Together has its own subgraph, all dApps have their own subgraphs, and indexers have to basically stake tokens to serve data on that subgraph. It's a very difficult problem because they're also trying to maximize rewards. Indexers are maximizing rewards. And so we solved the math problem for indexers, and now they have a tool that makes it easy for them. So we are currently going to be, especially starting next year, we're going to be growing more of the team on the ML side for the graph. And in particular, we're going to be doing a lot more multi-agent reinforcement learning. So you have two or more agents that need to learn how to either compete or cooperate. And if you're interested in these sorts of roles, please get in touch. And yeah, we're doing some interesting things. And it's not just on the algorithm side. We're also doing a bunch of ML ops. So how do you run a bunch of complex simulators in parallel? And how do you collect all that data in parallel? There's a lot of DevOps sort of flavored work that we're doing too. And on this topic, we have a workshop called WIMV Workshop on Mechanism Validation .dev. We just ran that in Amsterdam, and the next one is going to be in Bogota, Colombia, and we're going to co-locate it. I think it's called Blockchain Week. It's going to be co-located with DevCon, so it'll either be the week. Blockchain Week is either the week before or after DevCon, so we're going to run a workshop there. Okay, so we also do a lot. Half of our team, actually about a third of our team, is doing reinforcement learning and ML related activities. Another third of the team is doing zero knowledge proof work. This stems from the fact that we're originally a cryptography company. So we still have a lot of cryptography expertise in-house. And currently what we're building is a system called Roadrunner, which is a payment channel solution for the graph. It's going to allow for these massively parallel payments to be tracked through for all of the consumers and indexers, and it's going to save money for all the users in the graph for making payments. And related to that, we collaborate closely with Edge and Node. They've been working toward a ZKP based payment solution for several years. And we're also working with a famous ZKP professor at Georgetown. And if you have interest in ZKP, the best introduction to ZKP and snarks is this URL. Justin has a book on the topic, and the book is intended to take you from nothing to understanding, being able to understand the academic literature. It's not it's not a trivial book to read, but it's a very accessible book to enter into this space, especially compared to other approaches that I've seen on trying to teach you this stuff. And related to the Roadrunner work, we're looking for someone who knows both Rust and cryptography. Basically to work with the cryptography team to be able to implement the Roadrunner and there are going to be other systems that we're going to be building based on ZKP within the graph after our payment channels solution is released. Okay, so now we're going to transition into arbitrage, measuring arbitrage, our product that came out of this topic, and a few ideas for the hackathon. So arbitrage is a simultaneous purchase and sale of the same asset in different markets in order to profit in differences in the asset's listed price. It exploits short-lived variations in the price of identical or similar financial instruments in different markets or in different forms. So arbitrage, I'm sure, well, you probably have heard of it before. It's very common. The type of arbitrage we're doing most often exists in the foreign exchange markets, so for foreign currency. But those markets are so efficient that there is typically there's only pennies typically of arbitrage, and crypto markets are not yet efficient markets, and so we have much more arbitrage that exists in crypto markets. And the caveat is that there's a lot, just as in traditional markets, there's still a lot of competition in crypto markets to capture arbitrage because, well, I'll get into why. The paper that got us going down this, or the paper that got me interested in arbitrage, was an analysis of Uniswap markets. It is a very nice paper that explains how to calculate the optimal arbitrage conditions on Ethereum or other EVM or other blockchains that have smart contract languages. And yeah, so I read this paper. I came across it on the Zero Knowledge podcast through an interview with one of the authors, and this got me and then the rest of the team interested in this topic. We then took the paper, some of the algorithms, or one of the algorithms given in the paper that that explains how to calculate optimal arbitrage conditions. And just for fun, for ETH Global, we decided to build this westerngate.xyz website. And the whole point. Oh, thank you for posting the link to the book in the chat. Yeah, so the whole point of the Western Gate website was to measure arbitrage, and the novelty at the time for Western Gate, and maybe even still today, was that we not only measured single chain arbitrage, specifically arbitrage that existed only on Ethereum or only on Polygon or BSC, we also measured cross-chain arbitrage. So arbitrage that exists across chains. I'll show you in the next slide an example of that. The single chain arbitrage, these are all classically called triangle arbitrages because the simplest arbitrage would be, in this case, would be going from token A to token B and then back to token A. So let me walk you through what's going on here. We had, so yesterday, as many of you probably know, there was a lot of chaos in the market. And anytime there's chaos in the market, if you go to Western Gate, that chaos is always reflected at Western Gate. It's always reflected in the amount of arbitrage that you see across these chains because there's so much volatility happening. Pools get out of balance. And so here we saw that if you would input about 68,000 wrapped Matic into QuickSwap and swapped it with their wrapped ETH pool, which you would have gotten about 24 ETH out. And then you would have swapped that ETH for USDC also on QuickSwap. All this is actually in QuickSwap. And then you swap that USDC for Matic. You can see that you would have received about 1,000 more Matic. This was on Polygon. So this was on the Polygon chain. And yeah, so here you could see, even though we're only interacting with QuickSwap, but we're dealing with three different pools: the Matic ETH pool, the ETH to USD pool, and the USD to the Matic pool. The Matic was out of balance. The value of Matic was out of balance between these two pools, and this is how we were able to capture it. So here's an example of cross-chain arbitrage. So what if, with a cross-chain arbitrage, or actually more generally, it's called cross-domain arbitrage. What if you would have swapped on Ethereum? So this is a $600 arbitrage. If you would have swapped 47,000 DAI on Ethereum using SushiSwap, if you would have swapped it for ETH, and then if you would have swapped that ETH to WrapBTC, also on SushiSwap, and simultaneously on Polygon, if you would have swapped this amount, the same amount of Wrapped BTC for ETH and then ETH to DAI, you can see that we would have ended up with more DAI on Polygon than on Ethereum. Okay, so this sort of arbitrage on Western Gate, when you see this sort of arbitrage, what's interesting to me is that the arbitrage always sticks around longer. And why is that? Well, we don't have a way, if you're on single chain, we have ways to do atomic swaps using and you can use flash loans to capture this type of arbitrage. You can do all of this arbitrage in a single transaction. Of course, you have to have a smart contract that has these sorts of capabilities. But you could have a single transaction which lets you take a flash loan to get this Matic. Okay, so it's capital-free arbitrage. But on cross-chain arbitrage, how would you capture this? Well, you would have to have pools or reserves for this one, DAI on Ethereum, and you'd have to have reserves of WrapBTC on Polygon. And it's not atomic, so it's not guaranteed that it's going to succeed. A lot of times I call this probabilistic arbitrage, because things could happen so that one side, you can make your smart contracts such that this entire transaction will either succeed or fail, meaning if you don't get 48,344 DAI out, you can make the contract bail out. And so you only pay the cost of gas. So you're not stuck left holding anything because it fails. However, it's possible that it's possible that one side of the arbitrage succeeds and the other fails. So it's harder for you may be left with BTC on one side, and actually you may be left holding all of this BTC too, because this transaction failed. So it's harder to capture, and it sticks around longer on Western Gate. So with Western Gate, we became really interested in this topic. Actually, other people found it interesting too. If you search for Vitalik's Endgame blog post, he published it at the end of last year. You'll see Western Gate is highlighted in his Endgame blog post, and because nobody had built anything like this before. So we became really interested, kind of obsessed with arbitrage. I think everybody does who digs into it. I think this topic is a great entry point. I've talked to so many founders. So I think it's a great entry point into crypto, because it's just fascinating. And I talked to so many founders that now have businesses doing other things not related to arbitrage, just because they got fascinated by the topic. So we actually came up with, we're math people, we came up with a better optimization algorithm than what's commonly used for calculating arbitrage. It just so happens that the math that you need to calculate arbitrage is also what you need to calculate optimal trading. So we then created a new tool called Odos.xyz. Here's a screenshot of a new feature that we're going to be rolling out within, I don't know, sometime very soon. And this new feature lets you, let's say you have it lets you swap from multiple tokens to a single token. So let's say that you have you have Comp, Raptif, Aave, Matic, all in your wallet, and you'd like to make a single swap for another token, in this case, GRT. And if you were to do these individually, you'd have to pay 4 separate transactions and you'd have to pay the gas. Our algorithm can solve it can solve all of the optimal swaps to get you the most GRT, given that you want to take those input tokens, and it costs you less gas than doing them individually. So you can also do single swap. It's a DEX aggregator. You can also do single swap, single token trades with it. Okay, so we're still interested in arbitrage. There is a website, eigenfi.io. Thank you, Franz, for pointing that out. They've done a lot of work on this project. It's a pretty nice tool. I'd recommend checking it out. And we're interested in cross-chain arbitrage, cross-domain arbitrage. Specifically, what we don't know with Western Gate, I should have said, is we don't know who's capturing. All we can tell is, hey, there is this arbitrage opportunity, but we know you will learn, and you'll learn quickly if you look into this field, people are capturing all of this arbitrage, especially single chain arbitrage. But Western Gate's not about measuring how it was captured. It just says, hey, there's some imbalances in these pools. This is interesting. And an extension would be who's capturing this stuff, especially this multi-chain, cross-chain arbitrage. So this would be a hackathon idea. Really, this hackathon idea, we're not looking for you to extend Odos necessarily. We're really just, although Odos, we're still interested in potential future opportunities around cross-chain arbitrage, which is one of the reasons that we're suggesting that you look into it. But even for your own sake, we think looking into it is going to be, we think it's a worthwhile learning exercise and something fun, and you'll get a lot of interest from other people on this topic. Well, we're also interested in NFT ideas. Are there any Western Gate? There's a lot of markets being built on top of NFTs. Is there anything like Western Gate where we can measure arbitrage with NFTs? I don't know. This is just a wild idea. And finally, if you're into high performance computing or optimization, we have needs at Odos for optimizing all of our infrastructure related to solving optimal trading. And that's it. Thanks for attending.
Thanks, just on time. Does anybody have any questions? Maybe we can take one.
I have a question to Odos.
Sure.
So from my understanding, I thought it was like, let's say, it's like a transaction aggregator, right?
Yes.
So who would be the typical user? Because I could imagine a consumer may have multiple tokens and want to change it to, let's say, WETH or something, but is it more something for larger exchanges, or?
Yeah, thanks for asking, Franz. So this is it's a DEX aggregator. It's similar to 1inch. Even if you have a single token that you want to trade, it will pool the liquidity across all available DEXs. So right now, available means that we can integrate these DEXs into our optimization algorithm. So currently, we pool all the liquidity. We pool liquidity across 30 different DEXs, and we find your optimal trade to get from token A to token B. Now, if here in this case, I have a bunch of tokens that I've input, but that's just a new feature. The reason I'm flexing this is that there is no other DEX or DEX aggregator that can go from multiple tokens to one token. So that's a feature of our optimization algorithm, that we're able to efficiently do that. But you can just do one-to-one, once token A to token B, like you normally do with Uniswap or 1inch.
And yeah, if anyone here in the chat is taking part in the hackathon and looking to join a arbitrage project, I'm super down to partner up.
Yeah, I recommend collaborating with Franz. I've done some hacking with him in the past.
Thank you.
We just got a few questions, and Sam, do you have time to take them, or we can take it over Discord?
Yeah, yeah, I think I have time to take them if you want to spend 1 or 2 more. Okay. So does the engine you made include TX cost or the bridging of tokens between? No. So Western Gate, our hackathon project, does not include TX costs into this into the calculation. It simply solves kind of the more abstract problem, looking across these token pools. Yeah, and the cost of bridging. So bridging actually, bridging, yeah, is going to have to be, you're going to have reserves. In this case, you would have to have reserves of DAI and WPTC. And to actually make this a practical thing, in my opinion, you'd have to have pools, in this case of DAI and BTC. And these pools would have to be occasionally rebalanced. And these rebalancing efforts are going to have bridging costs associated with them. So this doesn't take that into account. Thanks for that question. How long do the arbitrage opportunities typically last? Go to westerngate.xyz and you will see. So today it's pretty quiet. I know the markets are quiet today because I looked at westerngate.xyz and I saw that there was almost no arbitrage available. And when that's the case, yeah, I just know things are quiet. But that being said, you'll always see small amounts of arbitrage, and you'll see, just check it out, you'll see it disappearing quickly. Okay, I think just because we're at time, I'm going to go to Discord. Today I'll check Discord, throughout the hackathon we'll be watching Discord, and you can ask questions there. Thanks everybody for attending.
Thanks, Sam. Thanks, everyone. See you at the next one.